Okay, so this is a test really of this learning glass. You'll notice that to my right I've got a copy of the A-level specification, and actually I can sort of look through that as I proceed. And what I'm going to start with, and we're going to see if this is actually the right way around, which it isn't. So what I'm going to do is transform, and flip it horizontally. That's perfect. Okay, so should we talk maybe about the double slit first? So imagine you've got two sources, A and B, and we consider what's going to happen a certain distance away on a screen. And we're going to make sure that the waves from the two sources, A and B, have a constant phase relationship, constant phase difference between them. Let's have them so that the waves are in phase as time goes on. What that means is, at the middle of the screen, we're going to get a bright fringe. Now, you should remember why we get this, and it's all to do with the path difference between the two wave paths, right? So we've got one wave travelling from A to point O, centre of the screen, and one wave travelling from B to O. They travel the same distance, as you can see from the diagram, and hence, if they're in phase at slits A, at sources A and B, they're going to be in phase at position O on the screen. Therefore, we get a bright central maximum, phase difference is 0, constructive interference. Now I'd like you to think to yourself, what happens as I move up the screen or move away from the centre? What's going to happen to the path difference? What's going to happen to what we see on the screen? So pause and have a think about that now, while you think how awesome this learning glass, how beautiful it is.